All right, this video is to help provide you with a solution for question number 3 on problem set 9.1 on rate laws. Here we again have a data table with 3 trials for the reaction of A and B to form products. We have the initial concentration of A, we have the initial concentration of B, and then the rate of the reaction, the initial rate of reaction for this reaction. First thing we're going to do is find the rate law. We're going to find the overall order. We're going to find the rate constant, but this one has a little bit of an extra twist, so we'll see what to do with that. So I'm going to move fairly quickly through finding the answers to problem A, B, and C. So as usual, we're going to start with the rate is equal to K times the concentration of A to the mth power times the concentration of B to the nth power. Those sound very similar. So let's focus on finding the concentration of A, the impact of concentration of A. So we're going to find 2 trials where B is constant. So again, trials 1 and 2 are constant. So we're going to focus on trials 1 and 2. So we will do A for trial, let's see, concentration of A for trial 2 is going to be over the concentration of A for trial 1, equal to the rate of trial 2 over the rate of trial 1. Of course, we're doing this because trial 2 at 0.080, that's bigger than 0.040, it just makes finding the exponent a titch easier. And then we're going to have 1.92 times 10 to the negative 5 as the rate from trial 2, and 9.6 times 10 to the negative 6 as the rate for trial 1. Okay, remember what we're trying to find is the value of m. So simplifying, we have 2 is equal to actually 2. And so you can see here that the exponential power there has to be 1. All right, now to find the impact of B on the rate of the reaction, we're going to find 2 trials, trial 2 and trial 3, where A is constant. So we're going to focus on trials 2 and trial 3. We see trial 2 is larger, so we're going to have concentration of, change that back to a regular color, concentration of B from trial 2 divided by the concentration of B from trial 3. And that's going to be equal to the rate from trial 2 divided by the rate of trial 3. So we're going to have 0.040 over 0.020 and 1.92 times 10 to the negative 5 divided by 9.6 times 10 to the negative 6. So we are going to look for that power of n. And so you're going to see here that again it's 2 to the first power is going to be equal to 2, so both of those are to the first order. Okay, so the rate law expression just becomes the rate is equal to K times the concentration of A times the concentration of B. So if I rewrite that, rate is equal to K times A times B. You don't even have to write any exponents there. All right, so that's part A. Part C, the overall order is the second order because the 1 plus the 1 is 2. Overall impact of the reactant concentrations on the rate of the reaction. Going back to question B, finding the rate constant, rearrange K is equal to rate over concentration of A times the concentration of B. Substituting in, again, trial 1 seems to be, just the go-to trial. 9.6 times 10 to the negative 6. The unit here is moles per liters per second. Divided by the concentration of A, which is 0.040 moles per liter to the first power times 0.040 moles per liter to the first power. Okay. So if we start to simplify this, we're going to see that the math comes out to 0.0060. And then if we start eliminating unit, moles over moles is going to cancel, liters over liters is going to cancel, remembering that this is still a 1 up here. And when we reduce that down, the unit is going to look like liters per mole per seconds. So there is our rate constant for this particular reaction. Okay, so now we have the rate law expression, and we have a value for K. And so when you have the rate law expression figured out and the value of your rate law constant, you can now figure out new rates of reaction if you have the initial concentrations that are not in this original data table. So this question, what is the initial rate of the reaction when the concentration of A is this value and the concentration of B is this value? So to figure this question out, rate is equal to K times A times B. All right, and to figure out the rate, we have all the pieces now. We know that K is 0.0060 liters per moles per second times the value of A at 0.12 moles per liter to the first power times 0.015 moles per liter. So we can see here, I'm going to look at units first. I see that this moles will cancel with that moles, and I see that this liters will cancel with this liter, so that's going to help us figure out our units a little easier. But multiplying these three numbers, you end up with 1.1 times 10 to the negative 5. And what units do we have left over? We have moles per liter, but we also have this seconds. So that right there is the initial rate for the reaction when we have A at this concentration and B at that concentration. All right, that's problem 3 from the Unit 9.1 problem, 9.1a problem set, and hope it helped.